so I'm pretty much tapped out for material, so I'll just show you something kind of cute that I threw together in some spare time. So I was on Hacker News one day, and I saw this library that somebody wrote called Did You Mean for Ruby. And so it overloaded method missing, so that when you type the name of an attribute or a method that didn't exist, it would say, oh, did you mean this other method? So I thought, could we do this for Python? And it turns out there's a lot of small ways you can do it for Python. You can use sys.accept hook so that you can trap an attribute error all the way at the top level and give a did you mean message. Or you could overwrite the built-in get attr. But I thought, is there a more interesting way we can do this? And so I came up with this. So let me pip install dutc did you mean. This will work on Linux and Mac 64 bits, but it won't work on, oh, we should do it on this one. We've got a virtual env in here somewhere, so did you mean? It'll work on anything but Windows. You can see it does something a little bit wild in the background, and I'll show you how it works. So let's use our Python here. So you have some class that you've written with some method, and you create an instance of the class, and you try to access the method. You misspell it, it gives you this error. You import did you mean, you try it again, and it says, oh, maybe you meant bar. And you think, oh, I wonder how he did it. So let me try to, maybe he used sys.accept hook. But if you use sys.accept hook, then if you did this, and you captured the exception yourself, the exception message shouldn't have my message in it. So I didn't use sys.accept hook. You might say, oh, maybe he did something to overwrite the get attr, because this will work with get attr. Or let me import. So let's just do this. Oh, see it there. So what I'll do is I'll get a reference to get attr, just in case he tries to patch that. And then I'll get attr. The message is there. And if I use the reference that I captured before, the message is still there. So as a module, this doesn't do anything interesting whatsoever. In fact, I think it's actually a fairly boring module. But what I think is really interesting is how I got this to work. So if you try and figure out how you got it to work, we can go into the did we mean, and I'll actually show you the source code for it. So I'll go into and you can see there was some C code in the background. So let's take a look at the C module that I create. A little bit of C coding here. And if you look through this, you can see something weird. I hooked PyObject getAttr. If you look at the very bottom, there's this function here called hook function. And if you look at hook function, you can see what I identified was there are different ways of hooking into a C executable, right? We have this LD preload. So if you have a shared object and you want to override the lookup in the linker for what it resolves to when you call a function in some shared object module, what will happen is you can preempt that, so you can do things like import your own or implement your own custom malloc or free for some debugging purpose. But unfortunately, within a Python executable, you can't do that because they're not shared object. It's just a direct offset. So what you have to do is something like this. What I wrote was a very simple little piece of code that finds the function in memory, smashes the top part of the function with a little jump, a trampoline, trampolines to my own function, and then implements that. And so the way that I got this to work was I found PyObject getAttr, the most fundamental entry point into the whole getAttr cycle, and I replaced it with my own one. Now, unfortunately, PyObject getAttr calls itself because it needs to call the dir command in case it needs to. I need to call a dir command in order to figure out by Levenshtein distance the method that you probably wanted, and that will call PyObject getAttr itself. So I ended up having to cut and paste quite a bit of this whole chain so that I wouldn't end up in infinite recursion. And the other interesting thing is, you might say, this is probably not what you should do. And you probably shouldn't do this because you're violating this kind of no execute principle. We have code and we shouldn't be able to modify this code. But in the process of looking at this, I noticed something very interesting. In Linux, you have this proc self file system that exports a couple of properties on the currently running process. And one of the things it exports is maps. And maps are all your memory maps. And what you can see is that for my memory maps, for something like a Python process, some of them are read-write and some of them are read-only. There's also something exported through the proc file system called mem. And you can see mem is read-write. What that means is, actually, irrespective of the read-write execute bits that are on that are on some part of memory, you can actually write through proc self mem to any part of memory that you want. And so you can implement this from a pure Python process and smash the stack however you want without having to write any C code, without having to do anything like I did in mine, where I have to actually call unprotect. I think it's munprotect. Or so that's did you mean. Thank you.
So what I did is I really don't use that much Python. I'm much more of an R person. So I wanted to sign up for a lightning talk to put some stakes in the ground and actually start coding in Python. Since I came to the conference, I got the t-shirt, this seems like the next logical step. Once this loads, I can actually get started with the presentation. Okay, so the first thing is kind of what is correspondence analysis? This is not a correspondence analysis, but this is going to help explain why we're doing it. Business people really like these 4-box charts. They really do. So there's only a few ways to do them. The most common way is just to start throwing, darts at a board that vaguely work based on whatever your 4-box chart in this case happens to be. There is a data-driven way to approach this, though, and that is a correspondence analysis. The quote at the top is from Wikipedia. In a similar manner to a principal component analysis, it provides a means for displaying and summarizing data in a 2-dimensional graphical form. How that works kind of behind the scenes is essentially just creating a difference matrix, and then it's slowly taking those distances between everything and finding out how it can squeeze them into a single box. In this case, what I decided to do is I decided to run through this entire process, which looks a lot prettier when I show it with little icons. So we're analyzing social media here. Social media is notoriously dirty. But using this process, we can take that dirtiness, somehow quantify it, and then create these 4-box charts with them. In this case, some dude is tweeting about Taco Bell, McDonald's, KFC, Chick-fil-A, whatever. And then they are deciding to give us that information, which we are more than willing to accept, take, and parse in Python. I still haven't necessarily broken out of R yet, so I did the final analysis in R, but I did find a code repository that has a correspondence analysis implementation in Python. If I ever want to refactor this code and perform it all in Python without, transferring it to a file, reading that file in R. The way that works is pretty simple. I'm reading data from Twitter, like anybody else would probably do in this situation. Then I'm parsing these tweets, just reading them out, casting them to strings, and then I'm just using that list with every single string that's available in those tweets to perform a lot of different transformations. First, I'm setting them to a set so I can get the unique different words that were used in those tweets. And I'm only using words that were used multiple times. I'm using somewhere between 3 and 6. There are 9 actual restaurants that I'm looking at in this data set, and I picked between 3 and 6 randomly because we don't want it to be too sparse, because then it's just making more data that we don't need, and we don't want it to be too large because most of this analysis is based on the fact that there need to be distances between the different restaurants. After doing that, I start to analyze my data, shrink it down, and I also create a word count again that's stored as a dictionary object that I will then use to create a matrix of the different words that I'm using in this corpus of the restaurant analysis. Finally, I'm kind of transposing that matrix to make it easier to then read into R later. Once again, that's kind of the gap in this analysis, is that I don't know how to implement this algorithm in Python just yet. And I start reading it into R. Another reason why it was implemented in R is because it was incredibly simple, and I only did this in 4 hours. So the single line to run a correspondence analysis, which is just CA with parentheses, was really helpful. As you can see, that's a mess. It's really hard to see what's going on under the blobs of red. To explain what's going on here, if it's blue, that means that's a restaurant. If it's red, that's a word that was identified. using kind of what I like to call the word hot list, which is me looking through my corpus of words, identifying things that look very foodie, such as fries, dinner, lunch, breakfast, burgers, hungry. I was then able to create a new list that's much more parsimonious and is allowing us to kind of see what's going on with the different restaurants in this analysis. Some interesting things that we can find out here is that a lot of people think Chipotle is an acceptable date. So that is, it's very popular on Twitter for dating. Also, breakfast at both Qdoba and McDonald's is a thing. So I used to work at Qdoba, so that's very near and dear to my heart. So I know how good the breakfast is, and I can recommend it. Also, bros like Burger King and Qdoba, not so much as hungry and craving people like Taco Bell. Obviously, this analysis needs a little bit more work. So I think over the next few months, I'm going to try to tune this, make it into a real presentation and talk that can be extended. So the next steps here would be to obviously pull in more data. Using the free API, I was only limited to 100 tweets. Getting more would be much better. From there, I could then use TF-IDF to identify which words only applied to food rather than using me looking at my giant corpus of words and seeing what looks like it fit with the food topic. Finally, I could use LDA to then shrink the list of topics in these tweets to group them together and provide a better distance matrix. Finally, I would then recreate the exact same analysis, both using correspondence analysis and multidimensional scaling, which is then going to shrink it to 2 dimensions, but also provide some interesting features around continuous vectors. Finally, if we add demographic information to it, in the same way that we have these red items here, which usually indicate a word, you can also overlay the demographics of the different people tweeting. And that's it. Thank you.
So, like some of the other talks, this one is also sort of a cute little trick to work around lots of this one particular issue that all of us have faced before, operating on a list concurrently. So we had an object in our data store, it's NoSQL, and it contained a list of items that we didn't really care about where their order was, where they were, and later requirements change required us to be able to operate on it and do so concurrently. So we could insert, add, remove. Basically, it was designed for real-time collaboration. So I want to be able to insert between 1 and 2. What do I have to do? I have to shift everyone over. So that kind of stinks. So in addition, we have some new constraints. One of them was we had multiple users operating concurrently. We had to now deal with this in real time to handle real-time updates, which we were doing, which was backing our Firebase interaction. We couldn't use locking or transactions because they were too slow. And our CEO said, of course, we need it yesterday. How many of us have dealt with that? So, yeah, welcome to fail. So we learned by failing. So our standard solution was lock the object, iterate over the list, lock those, and then do our writes. And it was slow, and one of the options was just deal with it. That wasn't a good option. The second one was taking advantage of the parent-child relationship of objects in NDB, which is our NoSQL data store, to simulate a list. This means that basically you can do what's called an ancestor query to get the list of results back and then order by some number, which we could call the index or the rank. And that was really slow still, not as bad as the first one, but we still had to lock on every single item after the insertion point. So it didn't really get rid of that first problem. So weirdly enough, I did not like either of these solutions, and I went home, and the solution came to me in the form of a question from my mathematically inclined daughter. She said to me later that night, how many numbers exist between 1 and 2? And all of a sudden, we had an answer. We don't have to shift them anymore. Whoever said that list ranks have to be integers? So if we combine the ancestor relationship to get rid of the list, so no locks there, and we don't have to shift everything, what do we get? We get exactly what we want. We can now insert into the list by reading the indexes of the 2 neighbors, and we can do this any number of times and maintain the original semantics. So insert something between 2 and 3, insert something else between 2 and 3. Who cares as long as they're both between 2 and 3, right? You fulfilled the contract. So this can be done over and over and over again, and it doesn't matter. And one of the things that makes this work is the precision of floating point numbers in Python, which are much higher than they are in languages like C and C++ and Java and so on, which buys us time to be able to change them back to integers when the server is less busy, when people aren't interacting with the system in real time. So, fractions to the rescue, right? Basically, the solution revolved around an implied list. Don't have to lock the object. You have a floating point rank, so you don't have to lock the siblings. And then you use an average rank or some other function to figure out where it's supposed to go. And then we can defer the rebalancing. So there are a few other pieces of it, like what happens if 10 people want to insert something between 2 and 3? Well, yeah, we covered that. We added an epsilon based off of time. So now all of a sudden, you can handle the concurrency, and everyone's happy. So if anyone has any questions, you can catch me afterward.
So I'm going to talk on behalf of the population modeling working group. And actually, I'm looking for people who will join that working group, if this interests some of you. I saw some modelers around here. Some of you may fit in this category. Probably most of you won't, but those who will, we want you to know about it and possibly join. So what is the population modeling working group? Basically, the background of it is we started under the hat of the Interagency Modeling and Analysis Group. IMAG is a government, a group of government people, and they try to promote modeling of simulation, not necessarily Python, many languages, many types of modelers and simulators. A lot of them are medical in nature, but not only. There are DOE, some others there as well. They have all sorts of working groups, data sharing, high performance computing. Population modeling is one of them. So in the last meeting that was there was some interest in the population modeling working group. A lot of people came over, and we kind of defined an ad hoc definition of population modeling as modeling a collection of entities with different level of heterogeneity. This is a very broad definition, and many things fall into it. Even yesterday, we saw here in one of the presentations, they shown a population of bikes. It will fall into this. The bikes are entities, and there's a high level of heterogeneity because they go and start from different locations. But think about populations of humans, population of cells, populations of animals. All of those are population models. And I'm going to show you some examples. I don't have enough to show everything, but I'm going to run through it, show you some slides that people left. So system epidemiology, basically clinical trials and models of those. Again, modeling diseases. This is from Netherlands, and you can see the population pyramid here that they modeled, and some disease there. This is called multi-scale modeling. This is modeling of the liver. This comes from different places, and you can get all those slides online. They're on our website in SimTK. Modeling social behaviors of mammals. There are networks of those can be modeled. Can be very complex population modeling, like preparedness for a disaster. Epidemiology, again, spread of disease. There's some YouTube attached to it if you download the slides. This is actually a population of cells, what's happening here. They're modeling cancer, populations of cells. It's another type of population modeling. Again, epidemiology, spread of disease. This is basically human behavior, what happens in case of a disaster. In this case, nuclear detonation, that's one example. Behavioral modeling, mental health models. Again, disease, this one is a chronic disease. You can find this, last year I presented it. This is actually a Python library. Also, they do evolutionary computation. You can download it and see what it does. Basically, genetic algorithms, also could fall under population modeling. Another example is discrete event simulation. Many of you know those systems, discrete event simulations. So they are used to figure out costs and utilities within hospitals. And even again, sorry, epidemiology, another one of those, spread of disease, and even musculoskeletal modeling, differences between different anthropometric measures or some other differences in the human body, musculoskeletal examples. So those are all examples, and we have some discussions on our mailing list, but I will let you go through it, and I would ask those who are interested or know people who do population modeling, just go to our website. You can take a picture of this QR code, or go and go through that link, or seek us out under SimTK, and just join the group if you're interested, and or just see what we're doing there. I'm done. Thank you.
3 slides here because I started working on this at the beginning of when James started talking, because he insisted that I give a talk. So you can blame him for all this. So the title of this lightning talk is Let's Do PyTexas. And I say let's do it because it's something that we all do as a community to kind of come together. And every year it seems to get more fun. There's a YouTube channel that has some of the recent talks. You can see that we've had some very good quality presentations in the last year. Some of the videos from the older years are kind of yet to be corralled, but eventually we hope to get them all up. So this is something about me, in case you have any questions. There's my email address and Twitter feed. So how to stay in touch, how to find out about announcements is probably the most, probably the best way is just to follow on Twitter. The main organizers of PyTexas tend to post on Twitter when there's new stuff going on. We also have a mailing list, texas@python.org, that is a place for everyone across the state to participate and have discussions, sort of without being limited to just your local user group. And of course, if you join, most of the local user groups are on Meetup, so I would highly recommend that you join your local user group. Anytime there's an announcement, generally the PyTexas organizers will post it to the local Meetup groups as well. And there is a global Python announce mailing list. So I'll just show you there. Here's the website for PyTexas, and it's 25th through 27th, was just recently announced. It will most likely once again be in College Station, which it has been for the past several years because it's really a wonderful venue at a low cost, and we don't have any any venue organizers stepping up in other places, so that seems like this is becoming a regular thing. The good thing is everyone who attends knows where it is, and we're hoping to boost attendance. I think we're in the kind of in the 200-ish range. Maybe we can get up to 300 this year. And here's the YouTube channel. You can see there are talks. You can of course go to pyvideo.org and find more a more complete listing of talks about PyTexas. Well, pyvideo.com.org, I think it's, yeah, this is the one. This is a great site if you don't know about it. Hey, I've probably run past my 5 minutes, haven't I? Oh, okay, good. Come to PyTexas, sponsor, attend, help organize, ask me if you have any questions. Mm-hmm.